This is part of the quality control program, so we're working on, pretty much right now we're working on developing a kit that would help farmers that are out in the field to estimate the amount of microbes and bacteria they can find in a certain amount of compost extract or compost tea. The main reason why we want to find this out is because it's far more practical for a farmer to use compost tea as opposed to using the actual compost. Most of the nutrients can be extracted through the extract or through the tea, and first of all it makes it more practical because the same amount of nutrients that you would find in 10 or 20,000 pounds of compost, you would have in 100 gallons of compost extract or compost tea. So it's a huge difference. Most people think that when we use a compost, there's nutrients or minerals that can be found there that are helpful for optimal plant growth. That's not exactly true. The main thing that helps plant growth is the microbiota in the compost. So when we produce a compost extract or a compost tea, that's where the bacteria are, that's where the microbiota is. So this is what actually helps the plants grow. All the other things are a little bit unnecessary. Therefore, we just focus on compost extract. That's why we need to know. We need to know how many bacteria are there in the compost extract. Now, if you go to the actually finding out exactly how many are there, that would be very tedious. Aside from the fact that by the time you get to count how many are there, they probably already doubled or tripled or quadrupled by that point. So the best thing that can be done quickly will be a quick estimate. So we're trying to work on a kit that would do that. We'll do an accurate estimate, the simplest estimate, accurate as much as possible, and in the shortest amount of time.
So, beginning of our experiment, this is how I start the experiment. So, this is our compost, which we brought from the rocket from outside. So we use some amount of compost and other type of stuff that I'm using for. So this is we use tap water, and our tea compost is inside it. We put inside the sack because we want to make sure that it stays separate from the water. And from there, after this tea compost is to stay 24 hours. So after 24 hours, I pour some of them in little beaker and then use for my experiment. After my I finish my cereal dilution and I start plating. And here I'm doing two different type of plating. And after I plate them, I leave my place, two different type of plates, as I said, from the cereal dilution. I put in the 37 Celsius incubator, and the other one I leave in the room temperature. As you see, those are different type of bacteria, really nice bacteria that I grow up in the place after 24 hours.
So we've talked about how to make the extract, we've talked about how to do the dilution and the plating. So now what we need, how many bacteria, the question is how many bacteria are in our sample, whichever sample we take. And that's where we come in right over here. We take the extract, we put it in these little test tubes here, but we can't really see anything from this because the humus is too dark. The humus is too dark, so because of that, anything we're going to try and do to read this humus, we're going to get a false reading. If you come right over here, this is the spectrophotometer. What we use this for is we use it to detect exactly how absorbent our sample is. So, like I said, back to this humus, if there's too much humus, it changes the sample, it makes it brown. So even if we do put it in there, we are not going to get an accurate reading. We're going to get a false reading. So what we need to do is we need to titrate this to make sure that all we're getting is how much bacteria is in there, not how much humus is in there. So, just going to show you a quick titration right here. So, titration to get the best results, you usually have to wait about 5 minutes. No, but since I've been watching those cooking shows, I know that you already have to have something ready made. So there we are right here. You see that? So now, what you have to do, oh, there's the sample. You see it? There we go. Anyway, we're starting the spectral photometer off at an absorbance of 0. So because we know that there's bacteria in here, we know that this is going to affect what the photospectrometer reads, the spectral photometer reads. So I'm just gonna put that in there. Shoots up. So now this is an accurate reading. This will give you an accurate reading of exactly how much bacteria is in here. So after we've gotten the readings, after Fakir has done the plating and after we have titrated it, what we're going to do is we're going to record those readings, and then we're going to correlate them. We're going to put them together to see if they correlate. Then we graph that. So so far we're getting very good results. We're getting a good correlation between the number of bacteria we see on the plates and the absorbance we're getting from the test tubes. Good results, we're getting good results, but like I said before, this is a work in progress. We're gonna keep trying, just like with the scientific method. You know, this is science, so we always have to follow the scientific method. We have to make sure that these results can be replicated. We have to make sure that, you know what, this just doesn't end in this lab, but it can be done on any lab, in any lab, anywhere in the world.
Even though we might be on the run and just come out of class, just check out on our results that we had in our plates and everything, because we actually enjoy this. I don't know. I mean, most people might think that this is like something dull and boring, and we expect results kind of like that. But science doesn't work that way. So I mean, it takes time. So we feel like there's gonna be a great outcome out of this. So that's why we keep working at it, and we enjoy this. So we'll continue doing it. Hopefully, we'll get great results, and farmers are gonna be happy, which means consumers are gonna be happy, which means we're all gonna be happy, and they all live happily ever after.
Absolutely. The end.